we have the result, which is the face blurred in real time. We have correctly detected the surrounding, the boundaries of the face, and then we have the blurring effect, which really well gets only the face and leaves everything else as it was before. Hi there, my name is Sergio and I help companies, students and freelancers to easily and efficiently apply visual recognition to their projects. Today we're going to see a simple task on how to blur a face from an image or from a video in real time. And this might be useful for projects where, for example, you need to display a video either publicly or for any purpose, and for privacy reasons, you need to blur all the faces that are on the video. So what are we going to see today? We're going to see how to achieve this in 2 steps. The first one will be, on a video, of course, you need to detect where is the face. So first step will be location of the face. And the second step, once we have the face, will be to extract the face, blur the face, and put the face back on the video. So if you're ready, let's start right now. Now, before you start, you need to make sure that you have all the libraries in order to run this one. You need, first of all, 2 libraries. One is Opencv and the second is Mediapipe. So how to install them? You can install them from the terminal. So we open the terminal, whatever, if you have Mac, Linux or Windows, it works the same way. Pip install Opencv Python. And then you press enter. I'm not going to do that because I have already Opencv. Then Mediapipe, pip install Mediapipe. And then you press enter. There is also one other thing. Consider that I already did a facial landmarks video. I'm not going to dive deeper into this one. So in order to make this simple, I created a file that before starting you need to download. And I'm going to put the link below on the description. So there is the blog post. You click on the blog post and you can download the facial landmarks file. It's this file which will allow you to extract the facial landmarks easily without doing any code, pretty much, so that we can focus only on the blurring of the faces. You download this link, you download this file from the link, and then you're ready to go. Now we're going to import CV2, and then we import Mediapipe as MP. Now I have a video. We can work with this video also with an image, it doesn't matter. We're going to load a video first of all, and let's track the face of the person. We're going to load it this way. Cap equals cv2.video capture, and then we put the path of the video. I have the video on the same folder where I have the code, and it's called personwalking.mp4, personwalking.mp4. How do we make sure that we're loading the video correctly? Well, there is one simple way. We show the video. If we don't get anything, it means that something is wrong. So we get the frame from the video, ret, then frame equals cap.read, and now we show the frame. cv2.imShow frame and then frame. Now finally a wait key event to keep the image open on hold, so to keep the window on hold. Key equals cv2.wait key 0. And let's run this one. Oh, it's huge. So it's so big that we cannot fit this, the video on the frame. So I'm going to shrink this one in size. Frame equals cv2.resize. We're going to resize what? We're going to resize frame. Now, when we resize something, we can choose either we give it a specific size, which we don't want, so I say none. Instead, we want to shrink half of the size of the width, so fx.0, and also half of the size of the height, so that we keep the proportion of the video and we don't need to give a specific size, so 0.5. And I'm going to run this one, and I'm satisfied with the results, so we can fit the video on the screen, and that's what I need. Now, The first step is to detect the face on the screen. But it's not only face detection, it's something more, because when we blur something, we want to blur only the face correctly surrounding the face. We don't want to blur all the bounding box of the face, so also decided it's not the face. So that's why we're going to use the face landmarks detection. I did a video about face landmarks detection, so I will not go in deep into details. Instead, if you want to know more about landmarks detection, check on the blog post below, because I will put some reference also of my other tutorial. And now, first step, face landmarks detection. In order to do this, we need to import the file that I've created. It's faciallandmarks.py that you need to put on the same folder where you're going to write the main file. So on the same folder with this file. And we're going to import that. So what we do from facial landmarks, we are going to import face landmarks. So even if this looks like we're importing a library, we're not importing a library, so keep this in mind. This is a file on the same folder that you have to download from the link below. And then, why did I create this file? I created this file because it makes so simple to get the landmarks that you have no idea. So we will load face landmarks with just one line. FL, which stands for face landmarks, you can call this whatever you want. FL equals face landmarks. Face landmarks. So what do we do? From the frame, we're going to get the position of the landmarks. Landmarks equals fl.get facial landmarks. And here, where do we want to get the facial landmarks from? We want to get them from the original frame. So we get them from frame. How do we make sure that we have the landmarks? I'm going to show them to you. So print landmarks. And you see we have a lot of numbers, because this library, this is based on Mediapipe library, which gives us 468 facial landmarks. And I'm going to draw just one of them so that you will see what this is. Landmarks, let's get 1 point. Let's take landmarks 0. So if I print point, so we have 468 of them. I'm just taking the first one, which has coordinates 1175 and 496. We show a circle, cv2.circle. You don't have to show the circle, I'm just showing this to give a demonstration of how we're getting the landmarks. EMG, we're going to display this on frame. Then the position of the circle is PT. We have X and Y in that one. Or better, let's say, point 0 is the X, point 1 is the Y. So we're extracting this coordinate and putting X and Y. What is the color? We can put, first of all, the radius. So we want to draw a circle. We need to say how big the circle. Let's say 5 pixels. We don't really care about the size. And then let's make this red. 0 of blue, 0 of green, and 255 of red. If we run this one, you see here we have a circle now. So this is one of the 468 facial landmarks. If I pick a different position, let's say 50, we have another facial landmarks right here. What can we do with all these facial landmarks? Well, I think that the best way to give you will be to show all of them, because it will make more sense later on what we're going to do for the entire face. Let's show all of them. For I in range from 0 to 468. So instead of having only one number here, we will have 468. So we loop through 468. We loop 468 times until we display all of them. This is what the first result that I wanted to achieve, to get the facial landmarks. Now, we want to blur the face. Here we have just points of the face, but we don't have like the surrounding of the face. How can we get this surrounding? The idea will be to get these landmarks, the boundaries, so only the landmarks that are the boundaries of this library. This will be an option. Or there is a better option in geometry which is called convex hull. So convex hull is pretty much giving us the external. So we're not going to, I'm not going to get into technical things about convex hull, but from this point, we'll get the surrounding of this point. So I think that solves the problem. Convex hull. Convex hull equals CV, CV2 dot convex hull of points of landmarks let's now try to show I'm thinking if we can, let's print convex hull. So convex hull, pretty much we're not going to have convex angles inside the image. So convex angle will look like this, where the angle is greater than 180 degree inside. And so that's why we get all the boundaries. I don't know if this gives the idea, but that's what it does. So from this, with the convex hull, we can draw a polygon. I'm not going to draw the landmarks anymore because you don't need that. Instead, let's draw a polygon on the convex hull. CV2 dot polylines. We want to draw the polylines on frame. The points are convex hull. Between brackets, that's how we draw polylines. Is the polygon closed? Yes, it's closed, so we say true. Let's display green polygon, 0 of blue, 255 of green, and 0 of red. And let's make this thick of 3 pixels. And if we run this, that's what is the convex hull it's about. It gives you all the surrounding. Now, how can we extract? With this, we finish the first step of this lesson. So we get the surrounding of the face correctly. How do we go further? Now, the step will be the second step to get the face, to extract the face, to blur the face. Once we have the face blurred, we will put the face back again. So there are a few steps on this one. Let's now extract the face. So this one requires a bit of experience working with Opencv because there are a few simple steps. But if you just miss one of them, it just will not work. So just follow carefully what I am doing right now. After the convex hull, we are going to do the second step, which is face blurring. Face blurring, I don't know why. Okay, typo in face blurring. Probably I'm misspelling face blurring. I will check that, the correct pronunciation, writing. For the moment, I will keep going with this. So I was saying that there are a few steps. First of all, once we have the convex hull, we need to create a mask. Let me show you the mask. Convex, how can we create a mask? So first of all, I need to create a black frame. Black frame equals mp.zeros. So a black frame is nothing more than a frame with, instead of having the color of the pixels, each pixel is specific, its own color, it will have all zeros because 0 is black color. So that's why np zeros, np.zeros. So we need to import numpy as np to do this. Import numpy as np, and this is the first step. Zeros. of the size of the image. What is the size of the image? We don't know that, so we need to get the size of the frame, which is height, width, and channels equals frame.shape. We use the size of the image to create a frame with the same size, so frame with height and width and channels, 3 channels, and then np.uint8. So this is how the black image is created in Opencv. Are we correctly creating the frame? Well, let me give you a demonstration. cv2.im show black. We can say this mask instead of black frame. Mask. Let's say black frame now. Or I'm going also to correct this one. It's good to give the proper terminology. Mask. Why mask? I will explain you in a bit. For the moment, let's run this one. I guess that when importing NumPy, I removed the, I canceled some line which I wasn't aware of. So from facial landmarks, import face landmarks, and let's run this one. So we have the frame, and then we have the black frame. Now, why mask? Mask is a concept that we use in computer vision to define. Here we will create a binary image where black is the part that we want to hide and white is the part that we want to allow. As we want to extract the face, we want to hide everything except the face. So we're going to draw white where it should be the face. To give you an idea, if I, on the mask, now we're going to draw a polygon with the same coordinates of the face. So exactly what we did before. Instead of frame, we're going to draw this on the mask. So the polygon, we don't need to draw the polygon on the original frame. Let's draw the polygon on the mask. So let's run this one. We have the frame, and on the same position of the face, we have this polygon. As I said before, the mask, the concept is black is what we allow, white is what we want, black is what we want to cover and white is what we allow. So instead of having this black, the mask needs to be white and 1 channel. So the mask will be either black or either white. It will not have different gradients of color. So I'm going to put this one and then this one here below. And let's run this one. Okay, now it's white. Black is what we cover, white is what we allow. Is that all? No, it's not all, because here we have only white boundaries, but we don't have a full white area. Instead, we want to allow the boundaries, but also we want to allow the inside of the face. And so what we have to do is, instead of drawing polylines only, we want to draw a full polygon with the full color inside. So we have another function, cv2.fillPoly. We want to draw a polygon with the color inside on mask, with convex hull. The convex hull are the coordinates, and then what color? White. So 0 is black, 255 is white. On the middle we have different gradients of gray. As this must be either black, either 0, either white, we put 255 because that's white. And we can hide now. We can now see this, which is not working as expected. This should be a full white, so I'm probably missing something here. Probably fill convex poly. Okay, that's what I wanted. With all these lines, we finally got, what did we get? We got the face. Now it's the step of extracting the face. So let's do that. we extract the face. So face blurring, extract the face. Where do we extract the face from? We extract the face from the original frame. Let me explain. How do we extract the face? Here is the face. On the original frame, we need to put the mask over. The mask is going to cover everything and it will allow only the face to display. And we use what are called the bitwise operators to do that. Face equals face extracted equals cv2.bitwise and frame again, because this bitwise is used also to link two images together. But as we have only one frame, we put frame twice. Instead, we use the mask. Mask equals mask. So the mask is the one with the face white. And let's now show the face extracted. cv2.im show face extracted, and then face extracted, and let's run this one. Okay, this is the mask with the face extracted. What now? What should we have to do now? Now the next step will be to blur the face extracted. So blur face equals save it. So we have different blurring functions. I have some video about how blur works, some video you can check on the channel or on my blog pysource.com. I'm going now to use some basic blur function with Gaussian blur. We define, what do we want to blur? We want to blur the face extracted. Then when we blur, we have what is called the kernel size. The bigger the kernel, the more the image will look blurry and will lose details. So usually we can keep this. It depends, of course, on the size of the image, but with 5 by 5 it should be good to go. And then here we don't put anything more advanced, we keep 0. Let's now show the face. To me it looks like it was before. So let's try to blur it a bit more. Let's use 19 and 19. Okay, I wasn't displaying the blurred face, so that's why. I was displaying just the normal face extracted. Okay, now the face is blurry. So the more we increase this, the more we lose details. So let's say 27, for example, by 27. And now it's even more blurry. Now we have to make the step inverse. We have to put the face back into the frame. And now it's a bit tricky. It doesn't work with Opencv that you just put this one and paste it over, because it just doesn't work. It will cover everything with this one. So there is another step where we have to make the opposite operation on the original image. So on the original image, on the frame, we need to extract the background. So on the one we extracted the face, which is the foreground. So face extract is the foreground. Now on the frame we need to extract the background, and then we can put them together. Extract background, and from the background, how do we extract the background? Same concept. We take a mask, black is what we allow, black is what we cover, white is what we allow. We need to have the inverse of the face mask. So background mask equals, how do we get the inverse? This is how you get the opposite of the mask. cv2.bitwise not to get the opposite of what? Of mask. So if we show mask inverse, background mask, We run this one. This is to extract the face and to cover the background. This is to extract the background and to cover the face. So now we have the mask. Now let's extract the background. Background equals same operation that we use to extract the face, cv2.bitwise, and we want to extract from frame. We cover the mask is the background mask. And keep following. It might sound hard, but it's not. It's a lot of small steps, simple steps, which will give you the result. We are almost there. Let's show two last things. We're going to show the background. Okay, background, and then background, and then we're going to show the face or the foreground. So foreground, and this will be blurred face. Let's show all of this. Background, foreground. Last, an easy operation. We have to put just this right away inside the background. Final result is result equals cv2.add. We're going to add what? We're going to add the background, and we're going to add the face, the blurred face extracted. And now once we reach this point, we can finally show the result. So cv2.im show result, and then result. And let's run this one. Okay, this is the result. It's already, we're getting something, but the final result, it sucks a bit, to be honest. There are a few things probably that we need to fix. One thing that, first of all, I notice is here on the face, when we are just close to the face, we see that it gets really bright all of a sudden. And I have an idea why we have this. Let me show what's my idea. cv2.im show blurred face. Let's show the face. So what happens that we cut this face at some point, and then at the end we're going to put the face somewhere else. When we cut the face, then we blur the face. During the blurring operation, the blurring is, it happens that on the images it gets a bit wider somehow during the blurring. So it happens that the boundaries of the face just get a little bit bigger. So when we overlap the face, we're overlapping also some extra boundaries. After the blurring operation, we could approach this in different ways. Either we could blur the entire frame, a copy of the entire frame right away. So we can do this. Let's try to fix these few things. And usually these are the operations that on a project are a big pain. These are the small changes which takes biggest part of the object. So I will try to do this as simple and as quickly as possible. What do we do? On the frame, we're going to make a copy of the frame, and we're going to blur the frame right away so that we overlap later the original frame with the entire blur frame instead of blurring only the face. After we get the frame, we can put frame copy this way equals frame.copy. So we have a copy of the frame which is exactly like the original frame that we're going to play around with. So we're going to blur this frame copy. Where? Let me find a place where I can blur that one. We blur this frame right away before extracting the face. So frame copy equals, we're going to blur the frame cv2.im. By the way, I'm going to use another blurring method that it's more, you see it more, it's blur. So cv2.blur, it's simple, a simple blurring method instead of Gaussian blur, and you will see the difference. We're going to blur what? We're going to blur frame copy. And then kernel size, let's say 27 by 27, exactly as we did for blurred face. Then let me show frame copy so that you know exactly what I am doing right now. Instead of showing, here we have the blurred frame. So one is the frame, and then we have this blur frame. Everything is blurred. From this one, we're going to cut the face. So how do we do that? We already did that operation somewhere here on the code. So face extract, instead of extracting the face from the original frame, we're going to extract the face from the frame copy, which is already blurred, so that we cut correctly everything right away. Now we can show the blurred face. Frame copy instead here, let's show blurred face, face extracted. And so this is the face extracted, so you see the cutting is precise. What do we do right now? Once we have this, we can again have the final result. So let's show this. The result is the background plus the face extracted. And I run this. I forgot to show the result, so let's do that. Result. Where is the, wow, oh, okay, I can see this one, and you can see how great now the result is. So now we have the face automatically detected, and also we have the blurring in real time. And now it's the moment to see this live. So how do we do this live? Well, it's really simple. Let's go up. Here we have, here we're getting the frame from the video. What is a video? A video is nothing more than a lot of images one after the other. So a lot of images in a second, this will make a video. So while true, simply we're going to put all this code on a while loop so that when we show one image and we're done with that, we go to the next image and so on, so that we show this in real time, this will show the video. And let's do the magic right now. We put this everything in the while loop. We say wait key instead of 0, which is freezing, is keeping the frame on hold. We'll say wait key 30, so it will wait 30 milliseconds between each frame. And then if the key is 27, we need some key event so that we can close this. So if we press 27, which is the S key on the keyboard, we want to break the loop, so we can quit. We release the video cap.release, and finally cv2.destroy all windows to close all the windows. So if we run this one, let's now show only the frame and the result. I run this one. We have the original frame, which is this one, and then we have the result, which is the face blurred in real time. We have correctly detected the surrounding, the boundaries of the face, and then we have the blurring effect, which really well gets only the face and leaves everything else as it was before. I hope that you enjoyed this tutorial and that you got useful information from it. And I share on YouTube these and many other tutorials, so I recommend you to follow if you're interested to know more about computer vision, while if you're interested to have more at a professional level, if you want to learn more how to perform tracking of objects, how to detect custom objects, and all these kind of things, I recommend you to check the website pysource.com, where you will find a lot of resources and professional courses for these tasks. This is all for today, and see you on the next video.